So, what is reduction? First of all, I'm going to explain what is the definition of reduction. Basically, the reduction is addition of hydrogen in the perspective of organic chemistry, especially. And second thing is the minus oxygen. So these two processes are said to be are known as reduction. So whenever any compound that is losing hydrogen, it is going to be reduced, or any compound, that is gaining hydrogen, it's going to be reduced. And any compound that is losing oxygen, that is also going to reduce. So gain in hydrogen and loss of oxygen, gain in hydrogen and loss of oxygen is said to be the reduction. How many different type of functional group or molecule can be reduced in your whole A-level chemistry syllabus? Here is the list. Number one, we can reduce alkenes. So alkenes are having the common feature. Alkenes can be oxidized and alkenes can be reduced. Both features are lying over here for alkene. Number two, carbonyl compounds. Carbonyl compounds. Carbonyl compounds are of two types. One is said to be aldehyde and others are said to be ketone. So again, they are having one common feature, you can say, that is here it was carbon-carbon double bond, and here this is carbon double bond, but not the carbon-carbon double bond, it's carbon double bond oxygen, carbon double bond oxygen. Third, fourth, fifth, generally, now I'm going to write the general perception or general hints. Overall, we can reduce, number one, once again I'm going to write carbon-carbon double bond. We can reduce C double bond O compounds. They may be aldehyde, they may be ketone, they may be acid, they may be ester, they may be amide. And we can reduce nitrile, C triple bond N compounds. So generally, overall, these three compounds can be reduced. It's alkene, and I'm going to erase it basically. It's not necessary to memorize the specific names, but you will have to memorize the general names. Alkenes can be reduced. Here is the list. Aldehyde can be reduced. Ketones can be reduced. Esters can be reduced. I think it's not in your syllabus, so I'm not going to count it. Acids can be reduced. Acid, whenever I'm going to talk about the acid, that is a carboxylic acid. Acid can be reduced, and amides can be reduced. So generally you can say there are these three different four compounds, different compounds, those can be reduced over here. Those are having C double bond O. They all, aldehyde, ketones, acid, amide, they all are having C double bond O in them. But as I told you in my previous part of the lecture, that only these two compounds are said to be carbonyl compound. Their functional group is carbonyl. And rest of this is said to be carboxylic compound, and it's amide, and so on. So that is, overall, the list of the categories of compound, those can be reduced. Alkenes can be reduced once again. C double bond O compounds, in which especially aldehyde, ketones, acid, amide, and C triple bond N, these are called nitriles. Nitriles can be reduced. Alkenes, C double bond O compounds can be reduced, and C triple bond N can be reduced. Now the next important thing is, what are the reducing agents? So reducing agents. Here are basically two group of reducing agents. Number one, first reducing agent is said to be lithium aluminum hydride H4, LiAlH4. It's a lithium aluminum hydride. For conditions, as you know, we must know about the reagent as well as conditions. Here we are going to use a solvent, ether. Ether is an organic compound basically. It is going to be used as a solvent. And what is the temperature or pressure? That is RTP, room temperature and pressure. 25 degrees Celsius. Lithium, aluminium, these two are said to be basically metals. Lithium aluminium hydride, in which basically this aluminium hydride is a negative sphere, a negative charge, and lithium is having positive thing. Positive ion. So lithium aluminium hydride is the basic reducing agent. The second in the same category, that is sodium borohydride. Again, these two are metal. They are almost similar. They belong to the same group. Aluminium and boron belong to the same group. Group number 3. Lithium and sodium, these also belonging to the same group. And here is the same number of hydrogen as well. So its name is lithium, then we call aluminium, then we call hydride. Hydride. Lithium, aluminum, hydride. Hydride mean any compound that is having H negative ion. This is called hydride. So they both are having H negative ion. They are basically H negative ion provider. They lose H negative ion. And this is the, almost similar class of that reducing agent. But its solvent is changed. We will use water as solvent, plus RTP. Now, what are the specificity of each of these two reducing agent? So, number one, this is used for aldehyde and ketones only. Aldehyde and ketones. That's all. So sodium borohydride is the relatively selective, or you can say the weaker reducing agent. But what about this lithium aluminium hydride? It can be used to reduce aldehyde, ketones, especially acids, and amide as well. Amide. So, lithium aluminum hydride can be used to reduce 4 functional group or 4 type of homologous series: aldehyde, ketones, acid, amide. But the sodium borohydride can be only used to reduce two functional group: aldehydes and ketone. So these are the basic point that you will have to cram, have to learn, have to have. And I think it will be much more easier to you to solve the question regarding this one. So this is the one group. This is called one group of reducing agent. But have you noticed that we are not, I didn't count this carbon-carbon double bond anywhere in this list. So these two reagents are having exception. What is the exception? I'm going to write it over here. Except carbon-carbon double bond. They cannot reduce carbon-carbon double bond. They cannot reduce carbon-carbon double bond. They can reduce aldehyde, ketones, acid, amide, and even nitride, but they cannot reduce carbon-carbon double bond. Let me mark nitrile over here as well. Nitrile. Yeah. So lithium aluminum hydride can reduce overall 5 functional group generally, and sodium borohydride can reduce only 2 functional group, but they both cannot reduce carbon-carbon double bond. Got it? Okay. Now there is a next group of basically reducing agent. One is said to be nickel, plus we use reagent hydrogen. Here this hydrogen is going to be used as a reagent. And what is nickel? Nickel is in condition, it is a catalyst. It's a catalyst, it's a reagent, and conditions in temperature we are going to use 300 or more than 300 degrees Celsius. Same is the case, the second one is platinum, the catalyst, reagent is condition, reagent is hydrogen, and condition is RTP. So generally speaking, whenever we are using lithium aluminum hydride and sodium borohydride, we did not add any hydrogen. But if you are not using this, if you are using just catalyst, solid metallic catalyst, then we use pure hydrogen gas. So in this group, in this category, we will have to use hydrogen. There is no hydrogen source. Here is the hydrogen source. Lithium aluminum hydrides are losing hydrogen, especially they are losing H negative ion. So there is a source of hydrogen. There is no need to add hydrogen, but nickel and platinum, they are just acting as a catalyst. So they are not going to have any hydrogen source. So we will have to add additional hydrogen. Plus in this case, we are going to heat. And in this case, we are going to operate at room temperature and pressure. So that is the second spell. It's the second group. It's the first group and it is said to be the second group. So there are basically 2 groups of reducing agent. So overall 4 reducing agents are over here. Now what is their specialty and what is their exception as well? The basic thing is, they can reduce carbon-carbon double bond. Yes, good. They can reduce aldehyde. Good. They can reduce ketone. Good. They can reduce amide. And they can reduce nitrile. Very good. So, they can reduce carbon-carbon double bond. They can reduce aldehyde, ketones, amide, nitrile, but there is one exception, except they cannot reduce this functional group. What is the name of this functional group? It's a carboxylic acid. Yes, it's a carboxylic acid. Okay. So they cannot reduce carboxylic acid. They can reduce, other than carboxylic acid, all the functional group that I wrote over here, that I told you initially. And same is the case, this lithium aluminum hydride group, sodium borohydride. Sodium borohydride is having the very specific application. They are just going to reduce aldehyde and ketones. Only 2 can be reduced by sodium borohydride. Lithium aluminum hydride can reduce 5 functional groups: aldehyde, ketone, acid, amide, nitrile. But collectively, they both cannot reduce carbon-carbon double bond. That is the exception of this group. What is the exception of this group? This group cannot reduce carboxylic acid. Now, my question is over here. Please think it and then, just concentrate on this page and then let me know, reply my question. The question is, if I want to reduce this carboxylic acid, which one reagent will be available or that is useful or that can be used? Please. I want to reduce carboxylic acid. Which one reducing agent can I use? Just acid, your carboxylic acid, there's one and same thing. Generally, first step is to please to memorize, to revise the list of carboxylic functional groups. all functional group, their nomenclature, I mean journal names, their structure formula, their, identity, you should, I mean, cram it. You should learn it by heart. From this page, just checking this page, which one reagent is suitable, which one reducing agent, reducing agent is generally known as a reagent, can be used lithium aluminum hydride, sodium borohydride, nickel plus hydrogen or platinum plus hydrogen, which one option you are having to reduce carboxylic acid? Two option, one option, and which one option? Good. Lithium aluminum hydride, just it can be used to reduce the acid. None of the other option is available. So you will remember this one. Lithium aluminum hydride is used to reduce carboxylic acid. Carboxylic acid can be used only with the help of lithium aluminum hydride and so on. Sodium borohydride is used to reduce how many functional group? So sodium borohydride, it can be used to reduce only 2 functional group. Lithium aluminum hydride, 5 functional group. Same is the case over here. They can be used to reduce 5 functional group. Nickel plus hydrogen, platinum plus hydrogen, 5 functional group. But there is exception once again. This group, nickel plus hydrogen or platinum plus hydrogen, cannot reduce carboxylic acid. And this one group cannot reduce carbon-carbon double bond and so on. So that is all about the reduction, basic of the reduction. Without example, I'm going to tell you the examples onward. But this is the basic. What is the definition of reduction? How many functional group or which type of bonds can be reduced? I told you here is the list of these compounds basically. And how many different reducing agents are those are said to be reagents for reduction are there? There are one group, this is the second group, and here are the condition. So again आपने इसको याद करना है, learn by heart. Organic chemistry, the basics of organic chemistry, and the easiest method, easiest way is to learn these points. And everyone has to learn. Everyone has to learn because this is a fact. There is no concept behind this sort of fact. इसकी अगर डिटेल में पढ़ाऊँ कि ये ऐसा क्यों है और ये क्यों करता है, ये T5 को क्यों करता है, दैट इज नॉट द पार्ट ऑफ योर सिलेबस एंड डेफिनेटली फिर तो मैं ऑर्गेनिक कभी ख़त्म ही नहीं कर सकूंगा ना. तो बेसिकली आपने इस लिस्ट को याद करना है और ये क्विकली अगर आप याद कर लेंगे तो इट विल बी वेरी quickly to solve the question, and organic chemistry will be on your fingertips. This is the shortest and highly applicable, highly efficient mechanism to cope up the organic chemistry, to be good in organic chemistry. Now I'm going to explain the examples. Examples now. Number one, if I'm going to reduce carbon-carbon double bond. For example, I'm having the smallest alkene in the universe, that is ethene. So what are the reagent and condition? You will choose it from this list and then you will let me know and I will use it. I want to reduce carbon-carbon double bond. Which type of reagent I require? Reagent mean reducing agent. Yes. Good. You can use platinum. You can use nickel. Good. So plus hydrogen. Basic reagent is hydrogen. In the presence of platinum, and here is the, if you are using platinum, I am going to write it over here, room temperature. Then what will be done? Now, this is the next phase. This one of the bond is broken down. When there are the multiple bonds, only one bond will be left. More than one bond will be broken. So here are 2 bonds, one will be broken, and I'm going to have this one. First of all, after breaking the bond, the shape of molecule will be like that. Got it? Now, Here are two hydrogen, and I can write hydrogen's molecule like that. It's also broken. HH bond is broken, and here will be one H, and here will be another H. So this is called addition of hydrogen, and as I have told you, as we have seen that addition of hydrogen is said to be reduction. So first of all, what was its name? Its name was ethene. It was a double bond. Now it is ethane. This is the same reaction that happens when, generally the margarine is formed from oil, and that is also said to be reduction and so on. Now, good. Now, the next example, I'm going to write it over here. That is aldehyde. This compound is said to be aldehyde. So, first of all, which one part of this group is going to reduce? Which one part of this group is going to reduce? Which one portion? No, no, no. Basically, C double bond O. C double bond O is the portion that is going to reduce. This portion is going to reduce, basically. As I mentioned over here, in my previous portion of this chapter, this lecture over here. This one, in all these cases, this group is going to reduce. So, yes. Now, what are the basic, can I use lithium aluminum hydride? Okay, can I use sodium borohydride? Yes. It's also aldehyde and ketones. It's a aldehyde, right? And all four options can be used. All options can be used to basically reduce this, because these two can also reduce aldehyde. This can reduce aldehyde. This can reduce aldehyde. So all these four options can reduce aldehyde and ketones. So aldehyde and ketones are the common. Whatsoever reagent you are going to have in your mind, you can put it, you can apply it. So if I am going to use lithium aluminum hydride, then I will use ether. Condition is ether. Usually they are asking to write on the arrow, or they can ask in a separate question. And here we will mark bracket, not H2. I am not going to write H2. I am going to mark bracket, square bracket, third bracket, and I am going to write just H, not H2. Whenever you are using the first one group, whenever you are using lithium aluminum hydride or sodium borohydride, then you will use simple hydrogen. This is called atomic hydrogen or nascent hydrogen. This is called atomic hydrogen. This is a newly born hydrogen. And you will balance this equation by this symbol of hydrogen, not with the symbol of H2. So what is supposed to be formed? Okay, let's see over here. There is a breakage of this bond. CO bond is broken down, and the molecule shape will be like that. C single bond O, H over here, and this is the basic molecule, remaining molecule of aldehyde. Now what will be added? Hydrogens will be added. One hydrogen will be added over here, and the second hydrogen will be added over here at the carbon. So one hydrogen at oxygen, one hydrogen will be attached with oxygen, and one hydrogen will be attached with the carbon. So this is the final shape or the compound of reduced form of aldehyde. What is the name of this compound, and what is this functional group? Let me know. Which one functional group is this one? Is it acid? It is alcohol? Is it aldehyde? Is it ketone? It's a carboxylic acid. You can check it from your previous list. OH group is lying over here on the carbon atom. Good boy. It's alcohol. It's alcohol. So what is its name? There's a two carbon. Two carbon names start from eth. Carbon-carbon single bond, you will write in, but you will not write E. And here you will write ol. Ethanol. One ethanol or just ethanol. In case of two carbon, there is no need to write one or 2. So this is basically, so whenever aldehydes are reduced, aldehyde, whenever aldehydes are reduced, they are changing directly into ethanol. Boom, khatam. Now come towards the ketone. I'm going to write the example of ketone. This is the shortest ketone in the universe, that is propanone. The shortest ketone. Generally, I'm going to write its family name, its homologous series name, ketone. And again, I will use this hydrogen. I can use sodium borohydride. And in the presence of water, this time I will write water over here. Then what will be formed? Once again, this bond is broken down. Only one bond is broken. CH3, C single bond O, CH3 over here. And every time you will add hydrogen, one hydrogen on oxygen, one hydrogen on carbon. And boom, it's answer. It's again alcohol, but that is a secondary alcohol. This one was primary alcohol, and this is the secondary alcohol. So every time whenever aldehyde or ketones are going to add, then there is a formation of alcohol. If you are using from aldehyde, it will change into primary alcohol. Whenever you are using, if you are starting from ketone, it will change into secondary alcohol. Now come towards the carboxylic acid. This is the normal carboxylic acid, a household carboxylic acid that is said to be vinegar. And again, let's suppose I'm using the first group reagent, lithium aluminium hydride. There is only one option that I can use. And then we will do the balancing the chemical equation later on. Let's see over here. What is this one? This is the carboxylic acid. And this time, this is a little bit different mechanism. There is the removal of this whole group. The whole oxygen is departed. The whole oxygen of acid is removed, right? And then here is C double bond O. There is a OH group. I'm not going to touch this OH group. What is the remaining part? The remaining part is CH3COH group. What is to be done? Again, to introduce hydrogen on this carbon. So this time, this is alcohol, and again, it's a primary alcohol. So whenever you are going to reduce, as far as your level is concerned, as Cambridge chemistry is concerned, you will change carboxylic acid into alcohol, that is a primary alcohol. So it's having lithium aluminium hydride, the only option, ether is the solvent, and so on. Now I'm going to balance all these chemical equation. The first one is a balanced equation. Come toward the second equation, I introduce 2 hydrogen, so I'm putting 2 over here. It's a balanced equation. And here is, again, I introduced 2 hydrogen. Nothing was lost from this molecule. So just putting 2 hydrogen, equation is balanced. In this case, we lost oxygen. We gain its oxygen. So 2 hydrogen over here plus H2O will be formed, H2O. In this case, whenever you are going to reduce carboxylic acid, whenever you are going to reduce amide, then water is formed. And this time, to balance this chemical equation, I will put 4 over here. Moreover, I can change the color of these hydrogen as well, because these hydrogen are taken from the reducing agent. So these are the new hydrogen. These yellow hydrogens are the new hydrogen, and the white group or white atoms are basically belongs to this original molecule. So in acid, aldehyde and the reduction of aldehyde and ketone is similar. There is no change in the group. There is no loss in this molecule, sorry. I mean, there is no loss of oxygen. There is no loss of oxygen. But whenever you are going to oxidize carboxylic acid, there is a loss of oxygen. There's a loss of oxygen, and yes, introduction of hydrogen. In first cases, I mean, aldehyde and ketone, there is only addition of hydrogen. There is only addition of hydrogen. But in acid, there is no addition of hydrogen. That is a little bit complicated mechanism. So basically, there is a removal of oxygen and introduction of two hydrogen on the same carbon. Now the next thing, the next example is amide. This is ethanamide, this one group. Again, let's suppose, if I'm going to use lithium, aluminium hydride, then I will use bracket, hydrogen. This is a symbolic representation of a reducing agent. In this case, again, I'm going to use ether. So what is happening? What is formed? So again, there is removal of this oxygen. If you are going to remove this oxygen, you will make H2O. You will make H2O plus. These hydrogen will be introduced on this carbon. Remaining part is this one, Ci3, CnH2, and you will add two hydrogen, one over here and one over here. So this time primary amine is formed. Primary amines is the product. So boom, water and primary amine. So whenever you are going to reduce any amide, you will make two compound. One is water, other one is primary amine. I mean, this is not the addition once again. And now to balance this equation, I am going to put 4 over here, and boom, it's a balanced. H2O plus this one question, the product. Now the last one, but not the least, that is lithium yes, I'm using again the lithium, or you can use any one mean. You can use this time I'm using nickel, let's suppose nickel, or and hydrogen over here, and that is at 3 degrees Celsius, let's suppose. So I'm using nitrile, carbon nitrogen triple bond. This is called ethane nitrile. 2 carbons, its name is ethane and nitrile. Ethane nitrile is the name. You can see that there are basically 3 bonds, triple bond I mean. So 2 bonds will be broken. Only 1 bond is left. Only sigma bond is left with this group. So what is the answer? Basically Ci3, C single bond N. So whenever you have broken the 2 bonds, so 4 hydrogens will be added. 4 hydrogen, 2 hydrogen to this carbon, and again 2 hydrogen to this nitrogen. So again, once again, it's again primary amine. This is also primary amine. It was also primary amine. So again, primary amines are formed. So whenever you are going to start from amide, or you are going to start from ethane nitrile, the destination is same. I mean, every time whenever you are going to reduce amide, or you are going to reduce ethane nitrile, primary amine is supposed to be formed. And I think that's enough one, or that's all about this one. For example, I'm going to write another molecule that is having cycloalkene. So again, it's an alkene. Let me know, can you suggest which one reagent is suitable to break this carbon-carbon double bond?
Okay. This is what again? What's the name?
It's an alkene, carbon-carbon double bond, cyclohexene. Its name is cyclohexene. Definitely. What is this one? Alkene. And this is also alkene. So I will write H2 over here. I will use nickel, 300 degrees Celsius, and this bond will be broken, and all carbon carbon will be single bond, and so on. So this time, if you are just simply removing the double bond, it means that these two carbons are having now two hydrogen, and this is said to be cyclohexane. Cyclohexane is the simplest way. Just remove the double bond. If you are going to draw the skeletal formula, then there is no need to write the new hydrogen. However, if you are not using the skeletal formula, then I mean you maybe use this one: CH double bond CH and CH2, CH2 and CH. So this time I'm going to add hydrogen under same condition, and it is CH2, CH2, CH2. This time I'm going to write 2 over here, 2, and same is the case, CH and 2 over here. These 2 are the indication of addition of new hydrogen, and so on. So you can also write in this way. This is also said to be reduction, addition of hydrogen, and so on. That's all about this reduction. That is a complete topic. Whenever, wherever they are asking the question about reduction from the whole organic chemistry, if you are going to have these points in your mind, you are simply going to have the full marks.